community of Bowness is underlain by a groundwater table that is directly connected to the Bow River. This model is intended to illustrate the relationship between the groundwater table, the subsurface sediments, river flow rates, and flooding within the community. It shows the river, the approximate location of the proposed barrier, and a street adjacent to the river with homes and basements on both sides. In cross-section, the sands and gravels and highly permeable paleochannels representing areas where the river was flowing in the past are visible. Note that the barrier, as per the current design proposal, only extends partway into the thick subsurface sands and gravels rather than all the way to bedrock. This means easy groundwater movement beneath it. Most years, the spring flow rate peaks at less than 500 cubic meters per second, leaving the groundwater table well below our basements, as you can see in the model. As the flow rate in the river rises beyond 800 cubic meters per second, however, a rate just above the 2005 flood flow rate, water begins to enter the lowest lying basements in the neighborhood, both on the river and some distance from it, depending on the home basement depths. As the flow rate rises to 1,230 cubic meters per second, the level favored by the city as per their design criteria, note that there is no direct overland flooding. However, at this flow rate, as the water seeks to attain an equal elevation to that in the river by flowing beneath the barrier, many basements and some first floors will be flooded as the groundwater comes to surface. This occurs both via seepage and through storm drains on the street to produce secondary overland flooding. This simple model clearly shows that the barrier design deficiencies and the city's failure to consider the local surface geology will result in widespread flood damage in Bowness, first in basements and then overland, despite the presence of the barrier. These damaged risks were identified in both of the engineering studies commissioned by the city after the 2013 flood. Only upstream mitigation, that is, intercepting and temporarily storing floodwater upstream of the city, can keep the flow rate through our community below the damaging 800 cubic meters per second level.